Hello people, welcome to yet another video of Random Fact Talks. Today we are going to explore space. If you're watching my video for the first time, please do subscribe to my channel for faster updates. What if I told you rockets can land themselves like something out of a sci-fi movie? With SpaceX, it's not just possible, it's happening. Today, we'll break down the science behind how SpaceX rockets slow down and land themselves. Let's dive in. The old way versus SpaceX. In the past, rockets were single-use. Once they launched, they burned up or crashed, costing millions every time. SpaceX revolutionized this by designing rockets that return to Earth and land safely for reuse. But how do these rockets actually come back and land? It's all thanks to physics, some clever engineering, and a lot of math. The physics of slowing down. When a rocket finishes its job of delivering satellites or cargo, the first stage begins its journey back. But it's moving incredibly fast, about 7,500 kilometers per hour, 4,660 miles per hour. To slow down, the rocket uses a retrograde burn, firing its engines in the opposite direction of its motion. What is retrograde burn? A retrograde burn is when a spacecraft fires its engines in the opposite direction of its motion to slow down. Let's look at the science behind it in simple terms. According to Newton's second law, F equals ma, the engines create a force, F, that pushes against the spacecraft's motion. This slows it down by reducing its speed. Firing the engines reduces orbit, making the spacecraft fall to a lower orbit or re-enter the atmosphere. The rocket also has a lot of kinetic energy because of its speed. To slow down, the engines need to reduce this energy by burning fuel and creating thrust. This is why the engines fire multiple times during descent. In short, a retrograde burn is like hitting the brakes in space. It uses the spacecraft's engines to reduce speed and change its path, whether to land, re-enter, or adjust orbit. Now, let's see re-entry challenges for a spacecraft. The rocket has to survive re-entry into Earth's atmosphere. At this stage, it faces extreme heat and pressure caused by friction with the air. Two major parameters are considered here: heat management and aerodynamics. To handle this, the rocket is built with materials that can withstand high temperatures. SpaceX also uses grid fins, those waffle-shaped flaps, to steer the rocket during re-entry. The rocket's shape and fins are designed to manage the drag force, which acts in the opposite direction of motion to slow it down. Drag increases with factors like air density, rocket speed, and surface area. Now, we are at the last step: precision landing. Finally, the rocket prepares for landing. To make a soft touchdown, it fires its engines one last time, known as the landing burn. This reduces its speed to almost zero right before landing. In this step, two factors are mainly considered: thrust control and autonomous guidance. The engines produce just enough thrust to counteract the rocket's weight, allowing it to hover briefly and land gently. The rocket uses advanced computers and sensors to calculate its position, speed, and landing target. It's like a self-driving car, but for space. At least for a moment, you might have wondered what difference this milestone in rocketry could make. By reusing rockets, SpaceX saves millions of dollars per launch. This makes space travel more affordable and helps us plan for bigger missions, to the moon, Mars, and beyond. Reusable rockets aren't just cool. They're the key to humanity's future in space. So, now you know the science behind SpaceX's amazing rocket landings. What do you think? Could this technology take us to other planets? Let us know in the comments. Don't forget to like and subscribe for more space stories.